In this video, we're going to review what we know about the complex numbers. To understand the complex numbers, and to make that review, we need to see how the complex numbers relate to some other number systems. There's a nice discussion about number in the Wikipedia article. I've hyperlinked that in the handout. We'll talk about the counting numbers 1, 2, 3, and so on that are common in almost every culture. There's a set called the natural numbers, which also has 0 in it. 0 is really kind of a big intellectual discovery. And you know, in Roman numerals, for example, you don't write 0. So there's the natural numbers, there's a set of numbers called the integers. We usually denote those by a capital Z. So we've got the positive integers, the negative integers, and we've got 0 in between there. There's the rational numbers, which are made up of ratios of numbers from the integers, except the bottom can never be a 0. So the bottom has to be a counting number. I'm using a version of Octave that's installed on my computer. Octave knows the complex number I. It always writes complex numbers as the real part plus a real number times the imaginary number I. It knows that I squared is equal to a minus 1. We could ask Octave to remember a complex number, 4 plus 3i, save it in location A. Let's ask it to remember another complex number, 2 minus 6i, save it in B. It can carry out complex multiplication. Now let's represent each of those complex numbers as a matrix. The complex number 4 plus 3i becomes 4 minus 3, 3, 4. Notice in this first column is the complex number. There's the 4 and the 3. As a matrix, the complex number 2 minus 6i becomes 2, 6, minus 6, 2. Notice in this first column is the information about that complex number. We can multiply the two matrices and get the complex number 26 minus 18i. Now notice back up here, when we multiplied the two complex numbers, we got 26 minus 18i. Now let's suppose that a is a complex number. For example, it might be 4 plus 3i. If we wanted to find the multiplicative inverse of this complex number, we'd be looking for some number so that a times that number is equal to 1. That would mean that x is equal to 1 divided by a. In our example, that would mean that x is 1 divided by 4 plus 3i. We learned earlier how to do division in complex numbers. We multiply the numerator and denominator by the conjugate of the denominator. In this case, when we multiply out the complex number times its conjugate, we get 16 plus 9, or 25, which gives us 4 25ths minus 3 25ths times I. Now let's do those same operations in Octave. First, I tell Octave my complex number, 4 plus 3i. So if a is equal to 4 plus 3i, then 1 divided by a is equal to this amount. The 1 divided by a was supposed to be 4 25ths minus 3 25ths. And 4 25ths is this number, and 3 25ths is the 0.12 that we needed up here. In its matrix form, that number is 4 minus 3, 3, 4. Octave has a command called the inverse of a. You can see me doing the inverse of a here. And notice that that's the inverse matrix. And notice right there is that complex number, the complex number 4 plus 3i. Another important item with matrices that we need to know is what the determinant of a matrix is. And the determinant of a matrix that's representing a complex number is simply the length of that complex number as a vector in the complex plane.